Today's lesson, we're going to talk about polar coordinates. So polar coordinate is to show the order pair with the distance and angle. It will be distance and angle, right? Instead of x-axis and y-axis. So if we're looking at example 1, we wanted to plot the points with the polar coordinates given. Let's try that. So if we have x-axis, y-axis, this is going to be distance and this is going to be the angle. So we wanted to go angle first from 0. So let's say this is going to be 5 pi over 6 degree or angle, right? And from that angle, you go 3. So it'll be 1, 2, 3. So this problem, they're talking about points right here in a second quadrant. So that point is called 3 and 5 pi over 6 in polar coordinates. So let's see, what about the second one then? Look like you have negative pi over 4, and negative pi over 4 will be going that directions. So it'll be somewhere here, which is this angle is going to be negative pi over 4. And then your distance of 5. 1, 2, 3, 4, 5. So that will be that point right here in our fourth quadrant. So this is going to be the points that is on the fourth quadrant. What about if you have C? So you wanted to go 3 pi. 3 pi is 2 pi is one circle. From one circle, you go pi more. So that's going to be 180 degree or pi. From there, you go 3.5 units. So if this is 1, 2, 3, 4, so then it goes 3.5, so it'll be right there. What about if you have negative distance, right? So you're going to find angle pi over 3 first. So let's say this is going to be pi over 3. And then you wanted to go negative 4 from that line. So you wanted to draw the line on the other side and goes negative direction. So it will be 1, 2, 3, 4. So that will be negative right there. So even though pi over 3 gives you on the first quadrant, but the point itself is going to be on the third quadrant because it's negative distance. For that reason, we can have multi representations of points, right? So these points can use this negative distance or use the positive angle with positive distance, right? And that's what it shows there. Let's use example 2 to show that there could be more than one representations of the points. So given 4 and pi over 6. So using 4 and pi over 6, we wanted to show when r distance is going to be positive. So let's find the point first. So that's going to be distance of 4 and pi over 6. So let's do, this is pi over 6. and that's going to be 4. 1, 2, 3, 4. So we're talking about this point right there. But with that positive, we can also show the negative angle. How do we show negative? We could go from here to this directions to find the negative angle, right? And that negative angle, how do we find it? We can do 2 pi minus pi over 6 because this is pi over 6, right? This is pi over 6. So we could do the positive. We wanted to do 2 more points with the positive. So we will do pi over 6 minus 2 pi, which will give you 4 and negative 11 pi over 6. So that blue theta, this, can be negative 11 pi over 6. And what else can we do? We can do the several rotations, right? So if I wanted to use the red, not just going into pi over 6, but after 2 pi, go pi over 6 more. That means you're going to do pi over 6 plus 2 pi, which is going to give you 4 and 13 pi over 6. Here, they want you to find 2 more polar coordinates with this time negative. So negative 4 and negative 4. So the same thing, the points we have is here. And this is pi over 6. So if I wanted to do negative, I need to find this lines, right? This line negative. So this line negative, the angle have to be either this angle, right? And then go negative directions. Once you go this angle, go negative direction. So it will be that point, right? So in order to do that, it will be pi over 6 in the third quadrant. So pi over 6 in third quadrant will be pi over 6 plus pi, which will give you negative 4 and 7 pi over 6. You can also do the negative angle too. Negative angle will be this directions, right? So in order to get that negative angle, you do pi over 6 minus pi, which will be negative 4 minus 5 pi over 6. So all these 4 points is talking about exactly same point, right? Same point, this point, but different way of writing, right? So we're going to try one more time. This time we have 2 pi over 2 is plotted, and we wanted to represent these points in different method. So it will be positive between 2 pi and 4 pi for A. And if we wanted to get that, we will do 2. And R is positive, so it means the angle is positive. So you will do 2 pi over 2 plus 2 pi, because they want to be between 2 pi to 4 pi. Then you will get 2 and 5 pi over 2. And B, R is negative, so negative the r being negative, this is going to be your distance. So they want it to have negative. And between 0 and 2 pi, so within one circle. So in order to be negative, you need to go on the other side of the coordinations. So you're going to add opposite side, so it will be just pi will be what you're adding. So you get negative 2 and 3 pi over 2. C, positive. Distance is positive. And they want you to use the negative angle. Negative 2 pi to 0. So you do negative angle minus pi over 2. Which will give you 2 and negative 5 pi over 2. Okay, now we're going to know how to convert from the regular coordinate, rectangular coordinate into polo, or polo to rectangular. In order to do that, we need to make sure we understand this part, right? And this part. So basically, make sure whenever you see x, you're going to replace r cosine theta, or the other way around, right? And y will be r sine theta. Depends on which one you wanted to change to which. And you can do x squared plus y squared is equals to r squared. And if you see r, you can replace with x squared plus y squared. Oh, this come with it, right? If you get this is just come with it. And then what else we have? Tangents, right? If you see tangent theta, you can replace with y over x or the other way around. So using this, we should be able to convert from rectangular to polo, polo to rectangular. So let's do example. We wanted to change polo to rectangular here, right? It's a polo to rectangular. So this one right here, we have 4 and 3 pi over 2. Don't forget this is distance and angle, and we're trying to change it to x and y values. So then we know that x is equals to r cosine theta. So when we replace this, your r is going to be 4. And theta angle is going to be 3 pi over 2, right? And when you replace that, you get 4 times 3 pi over 4 cosine is going to be 0, right? Do I need to show you that? This is that point, right? Which is x is 0, y is negative 1. Your cosine is your x value, right? So this is going to be 0. And your y is going to be r sine theta. So it will be 4 times sine 3 pi over 2, which is 4 times negative 1. Remember, sine is y value, negative 1. And this is going to give you negative 4. So converting this polo to rectangular, you're going to get 0 and negative 4. Right? 0 and negative 4. Let's try one more. So this one is going to be negative 2 for the r and negative 5 pi over 6 for theta. So when we replace that, will be cosine negative 5 pi over 6. That gives you negative 2. And we're looking at 5 pi over 6 is going to be pi over 6 in the third quadrant, right? This is negative 5 pi over 6. So the angle that we're looking at, actually, this angle, which is pi over 6. So cosine of pi over 6 is going to give you square root of 3 over 2, and third quadrant, so will be negative, which is equals to square root of 3. And do the same thing for y. Will be negative 2 sine negative 5 pi over 6, right? And that will be negative 2 times sine of pi over 6 is 1/2, but it's on the third quadrant, so it will be negative. That gives you 1. So the points, rectangular coordinate points on that polo is square root of 3 and 1. What about example 5? Example 5 is asking to convert this rectangular to the polo, right? So how do we do that? So this one is going backward as example 4. Don't forget, negative 3 and 3, we have x and y. We're trying to convert it into r and theta. So when we find that point, it will be actually negative 3 and positive 3. It will be somewhere right there, right? That's the point that we're trying to look for. So then we're going to use the formula. It's say r squared is equals to x squared plus y squared. Finding a distance, right? This distance right there. So that's going to give you r equals square root of, well, it's going to be plus minus, right? So then it's going to give you x is negative 3 square, y is 3 square, which you get plus minus square root of 9 plus 9 is plus minus square root of 18. So your r, you need to put it in a simplest form, so it will be plus minus 3 square root of 2, right? That's what square root of 18 is equals to. And then we wanted to find the theta. So because we know the formula of tangent theta equals to y over x, we can use that. So tangent theta is y, which is 3, over x, negative 3 will be negative 1. So in order to find the theta, we're going to do tangent inverse of negative 1. And the angle that gave you 1, we know that's going to be pi over 4. Pi over 4. So it will be pi over 4, but since it had to be negative, which is in the second quadrant, we know that will be on the second quadrant, right? So pi over 4 in second quadrant. So that theta is going to be pi minus pi over 4 will be 3 pi over 4. So theta is going to be 3 pi over 4. Don't forget the reason we know it's going to be second quadrant is because this point is in second quadrant, right? So we can write two different ways. Because we have plus minus sign, when the distance is positive, we have 3 square root of 2 with 3 pi over 4. When distance is negative, we can have negative 3 square root of 2 with negative pi over 4. Because negative pi over 4 will be here. And going backward will give you that point, so that will give you negative distance. Let's try one more with rectangular to polo. So you have this point. you're trying to find, so polar is going to be r and theta. So you're trying to find r, place it into formula. So x squared will be negative 5 squared plus y squared negative 2 squared. This gives you plus minus 25, 4, so it will be square root of 29. And then what was it again? Tangent theta should be y over x will be negative 2 over negative 5, 2 over 5. So finding a angle of tangent inverse with 2 over 5. Which quadrant is this? This is going to be third quadrant, right? Will be negative 5, negative 2. So it will be that third quadrant. This is third quadrant. The points should be on the third quadrant. So this in third quadrant, theta is going to be pi plus tangent negative with 2 over 5. This you can use calculator to figure out what angle that is, or leave it as it is in case you don't have a calculator. So then when distance is positive, you're going to get square root of 29 with positive. And if distance is negative, that's going to be just tangent of 2 over 5. Now we're going to look at how to convert from equations to polar equations. In order to do that, you need to remember any x you see, you're going to replace with r cosine theta. Any y, you're going to replace r sine theta. So if we use that, this first one right here, you can say 2 instead of x will be r cosine theta plus y r sine theta equals to 4. And we wanted to factor out r because once we replace it, we wanted to solve for r. So then when we factor r, we have 2 cosine theta plus sine theta remains equal 4. And in order to isolate r, you divide both sides by 2 cosine theta plus sine theta. So that will be the polar equations. What about this one? Do the same thing. Just replacing x with r cosine theta. So you have a square of that. Plus y r sine theta minus 2 square equals to 4. The next thing, once you replace it, next thing you wanted to say is simplifying and solve for r. In order to simplify, you need to get rid of parentheses. So let's distribute this. Distribute, right? And when you're trying to distribute this is 2 terms, so you need to FOIL that. So when you distribute the first one, you get r squared cosine theta square. When you FOIL this, you get plus r squared sine squared theta, and the middle term is the same term, so become 4 sine theta. Negative 2 times negative 2 become positive 4 equals to 4. And you can get rid of the comment from the both side. And if I'm just looking at this 2 term, I have comments of r squared, right? I'm going to factor that. Why? Because then cosine squared theta plus sine squared theta is equals to 1 using the identity properties. So then when we factor r squared, I get cosine squared theta plus sine squared theta minus 4 sine theta equals to 0. And we know this is equals to 1. So you get r squared minus 4. I'm missing r right there, right? For r sine theta equals to 0. And when you factor r out from those two terms, you have r minus 4 sine theta. So this will give you r equals to 0. Second factor will give you r equals to 4 sine theta. R equals to 0. Distance equals to 0 will give you origin. So that's not going to give you the equations. But this one will be equations. Let's try one more. So converting x to r cosine theta. And converting y into r sine theta. And then open the parenthesis, right? Simplify it and solve for r is what we're doing. So that gives you r squared cosine squared theta minus 2r cosine theta plus 1. When you FOIL this, because you have square for two terms. And this one will be r squared and sine squared. And so these two cancel out. And when we're looking at these two terms, you can factor r squared. And you get cosine squared theta plus sine squared theta minus 2r cosine theta equals to 0. And we know this is equals to 1 by identity. And it gives you r squared minus 2r cosine theta equals to 1. This is very similar to problem B, right? So we know we need to factor r, then you get r minus 2 cosine theta. Oh, that's not 1, 0, right? It was 0 right there. So let each factor equals to 0. This is not going to be equation because it's origin, but this is going to be, which is r equals to positive 2 cosine theta. So if we're looking at number 8, we're doing a backward. We wanted to convert it into polar to regular equations. So this one right here, when you see r, we're going to square both sides. Why do we want it to square both sides? We know x squared plus y squared is r squared. So instead of having a r, we wanted to make it as r squared. So if we square both sides, it will be r squared equals to 4. And we know r squared is equals to x squared plus y squared equals to 4. So that will be equations. What about B? So B, you have theta equals to pi over 3. So we're going to use tangent on this. So tangent, let me use the black. Tangent theta could be the angle. So it will be tangent pi over 3 in this problem. And tangent pi over 3 is square root of 3. And we know tangent is y over x is going to be square root of 3 now. So order to make an equation, you need to solve for y. So multiply both sides by x. You get x square root of 3 as the equations. The next one, C. R equals to 4 cosecant theta. Well, first, I wanted to change this cosecant into the sine. So it'll be 1 over sine theta. And you're going to multiply both sides by sine so we can get rid of fractions, right? So then you get r sine theta equal 4 is what we have. And we know that r sine theta right here is equals to y. So we're going to say this is equals to y, which is y equals to 4. The last one, the first thing we wanted to do is, remember when you're changing this x and y, then we know that x is equals to r cosine theta, y is equals to r sine theta. So you have to have r right here in order to convert it into x and y. So what you need to do in the beginning is multiplying both sides by r. If you do that, you get r squared equals to negative 8r cosine theta. So r cosine theta, we should be able to change or convert that into x. And we know at the same time r squared, let me just erase that for a second. So this will become x squared plus y squared. And we wanted to solve for y, but then knowing that having a square on x and y, this is going to be a circle formula. So let's just put it all one side. How does circle form? A standard form of circle is what I'm trying to say. So we wanted to put everything on the left side, just the number on the right side. So then you're going to make this equals to x squared plus 8x plus y squared equals to 0. And in order to make this one a standard form of the circle, you're going to add 16 on this side. It means you need to add 16 on the other side to not to change the given problem. So you get x squared. Well, you can factor that, right? X squared plus 8x plus 16. And when you factor that, you get, let me just erase it. You get x plus 4 squared. So you're factoring this, right? Plus y squared equals to 16, which is going to be 4 squared. And that's going to be the equation, standard form. So we covered in order to convert equation to polar equation, so polar to regular equation, we will need these formulas right here.